Well, it's breezy out here, but it is pretty sunny. The sun's just about to peek from behind those clouds, and then I think I've got a decent window to test a solar charge controller. But I'm going to have to get a wriggle on because, well, this is how this solar charge controller has arrived. It's in bits, and I'm going to have to put it together before I can test it. So without further ado, let's get these packets open. So we'll start left to right, I think. We'll open this up. There's some connecting wires, and in here is a little LCD screen that will come out of this bag. There we go. And yeah, that looks like it's a blue backlit screen. There's the connector. A little bit of flux residue on there, isn't there? But yeah, that'll be fine, I'm sure. The big package in the middle here, well, this is the main item. It's time for a new knife, isn't it? Let's see if we can get in here. This is pretty well wrapped in bubble wrap, isn't it? Yeah, right. There we go. This thankfully wasn't going to suffer any damage in transport, was it? Oh wow, yes, very well packaged. And there's the well, the main board for this MPPT solar charge controller, and you can see here it's an MPPT Solar 20A, so 20 amps, and yeah, that's it. It's got a big inductor there, decent size inductor, a couple of transformers there, plenty of caps, and on the back, well, yeah, there's some MOSFETs and some diodes, perhaps. Oh no, they're big power MOSFETs, I think. Yeah, they're quite chunky, aren't they? Yeah, pretty good. So yes, that's the main board, and then the final bit over here is pretty straightforward. This is just the sort of screen surround, and you can see it's got a wire there because there are 4 buttons built into this, and this just, well, sticks onto something. Whatever, I guess, that you put this into, this will stick on, and you can control this and obviously mount the screen in that little window there. And yeah, this is a MakeSkyBlue solar charge controller. Now if you look on eBay, there are loads of these MakeSkyBlue solar charge controllers, and usually they're in a big aluminium box with a big fan up here. But this one was sold on AliExpress as a do-it-yourself kit, which I thought might be a little bit more interesting perhaps. But it does mention, of course, that you need to think about one thing, and that thing is, well, these MOSFETs at the back. It suggests, yeah, you need to think about a heatsink. So I have had to buy a heatsink separately, and here's the heatsink that I ordered, and this was a little while ago, but again, this one came well wrapped in bubble wrap, and this was from a more local supplier, because heatsinks being heavy tend to be roughly the same price if you get them from a long distance or a short distance. But yeah, that's quite a hefty heatsink, isn't it, that I've ordered there. This is a 100mm by 100mm, that's right, and that should just about, yep, that seems to fit okay. There's just one thing that I've thought about. I haven't got any insulation for these MOSFETs to electrically isolate them from the heatsink here, so I might have to think about that. Yes, that might be a problem. So let's take a quick look at this board here. I imagine at the moment it's still solar on the left, plus and minus, battery in the middle, plus, minus, and load. Plus and minus, that inductor is fairly chunky, isn't it? There's a resistor down here, R31, just a chunky piece of wire. That's obviously doing current sensing, isn't it? So that might make sense from the solar positive to the battery positive. We'll have a look at the back in a second. The microcontroller up here is, well, you can probably see that better than I can, but yeah, I can't see any obvious manufacturer on there. A 3.3 volt regulator up there for that microcontroller. These transformers, which I'm again not entirely sure what they're doing in here, and the caps, which are presumably on the input there, rated for 80 volts. And what's that one on this side? There you go, 50 volts on the sort of output side. Yeah, that all seems fairly straightforward. The screen and the buttons connect up here at the top, and if we take a look, there's clearly, I would suggest, they're unpopulated opto-isolator points there, aren't they? Because there is isolation in there and just two soldered up points on each side, so they look like optos. And yeah, there's a few bits that perhaps haven't been populated on this version. At the back of the unit here we can see all those MOSFETs, and on here we can see that these two terminal points are connected together, and that also connects to this point here. So that is where a capacitor sits, and that's the positive side of that capacitor. So this must be battery positive and load positive, and that means that this is a common positive charge controller. So after a bit of trial and error, I found that these three devices, all the tabs are common together now, so they can all touch the heatsink there without it causing any electrical issue. These two over here are also connected, but they're not connected to the tabs of these devices on this side of the board. This one here is completely independent of everything, so I need to make sure that this is isolated, and well, I guess these two also need to be isolated from the heatsink, and these three can all touch it without any sort of electrical insulation. So I've had a good dig around the shed and I've managed to find some of these. These are little pads. They're sort of thermally conductive but electrically isolating, insulating. So yeah, that should be able to sit on the back of that MOSFET and isolate it from the heatsink, hopefully. And do you know, will it just about? I think it might just work on that one as well, and obviously it'll work on this one up here. So hopefully 3 of these should be enough. Now these came in little kits. I bought these years ago on eBay. Little heat sinks for MOSFETs or whatever. It comes with that insulating or thermally conductive tape there, and a screw and a little washer to isolate the screw as well. So yeah, hopefully I've got 3 of those and that will do the job. And I guess if I've got some thermal paste that hasn't perished over the winter, that will help just sort of stick it in place. Yeah, we'll give it a go. Okay, I've got some thermal paste here, but that's paste. Heatsink plaster. I think this might be better because I think it's meant to be a bit gluey, but it's also quite hard. Might have to work at that a little bit and just see if we can get it going. Otherwise, it will have to be one of these, the thermal grease or the thermal paste or the heatsink plaster. Which one will it be? So I found some M3 machine screws which seem to fit reasonably well and will go into my heatsink a few millimeters. So hopefully that might work. We'll have to see. That does mean though, I think I'm going to have to try and tap this aluminium heatsink, which is something I've never done before. So what do I need? A 2.8 millimeter drill bit? I bet I haven't got one of them. Right, there's not enough room, I'm afraid, to show you drilling, but I've got a 2.5 millimeter drill bit here, so hopefully that'll be roughly right. So I've got my 2.5 millimeter holes in there, and this is an M3 tap. Never done this before. Not sure quite how it's going to go. I think you're meant to twist it forward a bit and then come back again. Oh, it's wobbling about a bit at the moment though. Will somebody remind me to get self-tapping screws next time? That took forever. Hopefully I've done a good enough job. Yeah, so I've got the heat compound, the thermal insulating, you know what I mean, little pads. Everything should be good to go, I think. I'll just take the wrapper off here. Right then, let's see if we can get some paste on these just to hold that insulator on. Oh, that's... yeah, that's not ready to go, is it? No. Well, there does seem to be some inside. Perhaps I'll just put a hole in there. Yes, that's working perfectly. And then I need to place these on the 3 on this side. That looks almost neat now, doesn't it? Now, do you remember those little insulators that I got in these packs? They seem perfect to just put in there, and make sure that this screw doesn't eat away at the solder mask here and make any contact. So yes, I'll definitely get another one of those. That seems to work quite well. And then we'll screw the heatsink on to the charge controller's main board, and then hopefully within a minute or two we'll be able to test this. Well, there we have it. The 2 screws are in and tight. It's not quite level, is it? That's a bit of a shame. But hopefully that will be enough to keep all those MOSFETs cool. It's a hell of a heatsink actually, isn't it? So it's time to plug the screen in, and it's quite a long cable. I guess that's nearly a foot in length, 30 centimeters, 25 perhaps. That can only go in one way because of the little lugs on this JST connector. Can't remember what type it is, but there's the screen, so that's all sorted. And then we've got this. Now let's take this protective coating off. Yep, so it doesn't indicate which way round this goes, but I guess they're only buttons. But it definitely goes to that connector because it says key 1 up there right next to it. So hopefully that will be sufficient. Let me untangle these wires and set everything out a bit nicer. So I've tried to make this look nice, but I realised then that this screen, which is floating around still, I don't know which way up the screen actually is. I now need to connect some power to this, and I'm pretty sure that this terminal here is positive and this one is negative after we looked at the back of this unit. But I'm going to connect it to my bench power supply to start with, which is set to 12 volts and just 100 milliamps just to make sure. So oh yes, I have something on the screen that's not showing up very well. Let me adjust things. It's that way up, isn't it? And yeah, let's see if we can get a better image of that. Sadly, I'm struggling a bit, but if I hold it here, that's about the best I can manage. On the screen, there is what seems to be a battery icon showing a low voltage, and that's unsurprising because at 200 milliamps, this solar charge controller has dragged my bench power supply down to 6 volts. That can't really be pulling 200 milliamps, can it? There we go. Alright, now, so it's now pulling at 12 volts 100 milliamps, which still seems quite a lot, doesn't it, for a charge controller that's not doing anything. But the battery icon is showing now a higher battery, and we can see the PV, it says no volt and no watts, which is correct because nothing's connected. If I press any of these buttons, enter wakes up the screen, which is nice, but up and down don't seem to do anything. I wonder if that connector's the wrong way round. Let's just flip that around. Oh, there's an LED on board. Didn't know that. It just says blink next to it, and that's exactly what it's doing, isn't it? Blinking. So there we go. Right, now the buttons are the right way round. we can see that the PV voltage, no voltage, battery 11.8 volts, output 3, and apparently it's 19.2 degrees Celsius, and there's possibly a fault number, which might mean that there's no PV. It's all a bit unknown, this, because it's no manual. I've put it together myself, hopefully correctly. Yeah, let's have a little play. Let's have a think about what we can do. Right, I don't think anything's going to go bang, so I'll plug my battery bank into this now, because I've tested it on my bench power supply, and that's looking a bit healthier, isn't it? There's a decent battery voltage indicator. There's a moon to say that there's no solar. Well, yeah, that's correct. PV, no volts, no watts. It seems to suggest the output is on. And what happens? Well, that seems to be the programming menu, which makes sense. PRG. And if you go the up and down, then you can see now the battery parameters, 12.5 volts. Well, that's probably about right, because I've been trying to drain my batteries down a little bit. Output 3.0. I still don't understand that. 19.6 degrees C. Well, that might be about right in here, possibly. It's still suggesting a fault. And 18, is that no solar perhaps? And that goes through the menus. Enter. What does enter do? Can we turn the load off? No, can't seem to turn the load off. Press and hold down. No, that doesn't seem to do anything. That is just going through that menu again. Yeah, not sure about this yet, but either way, should we plug some solar into it and see if it works and if it's doing MPPT? It's always a bit difficult to get everything in for these experiments, but on the right hand side we can see 12.6 volts on my battery bank, and this is still consuming 95 milliamps, 1.2 watts, which seems a little bit high, but the backlight's on, I guess, and it's thinking about solar, so perhaps we'll forgive it for that for now. On the left hand side, this portable meter is about to show the voltage of some solar panels. I'm not messing around here for this experiment. I've got two 100 watt solar panels connected in series, giving about 42 volts open circuit over here when I connect them up. A maximum power point about 35 volts if this is doing MPPT, and hopefully we should see a reasonable level of conversion from, well, hopefully 35 volts over here down to 12.5, 12.6 volts on the right hand side. So without further ado, let me get those connected in. Bit of a crack there. 42 volts, dropping now down to 34. That seems pretty good. 2.5 amps, 90 watts currently being created by those two solar panels, and that does seem to have made this go a bit funny, which actually, thinking about it, 36 volts, 2.5 amps, 90 watts, well, that's going to be over the 5 amp rating of this device, isn't it? Perhaps I need to reduce the amount of solar that's coming in for my portable meter. Right, bit of a mess this, isn't it? But we've got the voltage of the battery now here. We'll hopefully show the current on the Unity meter in the middle, and of course the solar coming in on the left hand side. So if I plug the solar in, 43 volts, 200 milliamps, 2.5 amps. Yeah, look at that, 6.5 amps. The Unity is claiming going into the battery. Can we see that? Yeah, 6.3 amps. So we've got 100 watts coming from the solar panels, and bit of maths there, 13 times 6 is what? Well, I make that about 78 watts. 6 times 13, 78. Is that right? Have I done the right maths? So 95 watts coming in, about 78 watts being calculated on this side, and clearly a much higher voltage here from the solar panels, 40 volts there, going to my batteries, which are now creeping up to 13 volts. So yeah, this is clearly doing MPPT. Now, is anything getting warm? Don't think so. That heatsink must be doing its job. Excellent. So I think that's probably about as far as I want to take this today. I've managed to build an MPPT solar charge controller. Well, I've managed to plug in some buttons and a screen and mount the mainboard to a heatsink. I can see applications where having the screen and the buttons slightly removed from the controller itself might be quite useful. If you're building it into your own sort of control panel, that might look quite a bit neater and have this hidden behind it. But financially, with this at $29 for the kit and that extra expense of the heatsink, well, it's about the same as many other cheap MPPT solar charge controllers. I'm obviously going to have to look up a manual for the MakeSkyBlue MPPT solar charge controllers, aren't I, to work out this menu, but that's for me to work out at some other point. Hopefully you've enjoyed this video. If you did, give me a thumbs up, subscribe down below, comment if you can, and I will see you next time. Thanks for watching.